Hi, and thank you for joining me as I explore the site material management solutions for progressive congestion analysis functionality. My name is Robert Oberlander. I am a second year student in the MSCM program, and I thank you for taking the time to walk through this project with me. To begin, at the inception of this course, we were instructed that the main component for our grade at the end of the module was going to be a research project revolving around two components. One, a paper that put forth our methodology and results, and then secondly, this presentation to explore the project scope and the results in a visual format. So to begin, we were allowed to choose our own topic, and a previous project of mine resulted in some very heavy site congestion and inter-workspace trade stacking that unfortunately resulted in a loss of productivity on the job site. So I was tasked with determining what sort of either pre-planning or software solutions were available to solve this problem. Now, we were never able to implement that solution, but it did provide the genesis for this current project. The proposed research topic that I started with was site material management and the impact of construction logistics planning on minimizing site congestion. Some of the key words found through this scope are temporary facilities, site planning, congestion analysis, material movement, and planning software. Early on, we were asked to identify the research problems to overcome, and those were along with becoming more familiar with research methodology in an academic setting, which is not something that I've done since leaving school back in the early 2000s. But in addition to that, there were a limited number of defined or widely accepted software systems to study. This component of pre-planning is not as popular as other pre-planning components to which certain functionality has already been included in certain widespread platforms. Also, the uniqueness of every construction project prevents a uniform solution applicability. Um, the one fun thing about construction is that no two jobs are ever the same. And unfortunately, that means that your software applications have to be um, able to handle a diverse number of site condition, uh, labor constraints, time constraints, cost constraints, to be able to be effective in their proposed arena. And the third research problem that I was due to overcome is having to dive through the variety of different congestion types that can occur on a construction site. There are spatial, there are scheduling with respect to equipment and labor. There is stacking of trades in what may be considered to be a wide open space, but if you have, say a plumber coming from one direction in their work of order and an electrician coming from the other and they meet in the middle, well, you're going to lose time and lose efficiency with the conflict that results. So the research questions that I was posed with early on during this process are what are the current techniques or software programs or design processes that active construction managers use to effectively pre-plan away any on-site congestion. What are the project parameters that best align with the deployment of a particular technique? You will explore a solution that revolved mainly around earth moving equipment. It was a rather static procedure that involved grid working and predefining the routes of movement for equipment and personnel. So not every solution is going to fit every project type or project conditions. Um, the third question is, what are the limitations of each technique? If all of these uh, platforms and all of these systems were synonymous with one another, then I'm sure that there'd be a bevy of research to complement each, but unfortunately that's not the case. Um, the most critical component for uh, the four-dimensional capabilities of each technique, as defined by myself, is the ability to forecast into the future and to be able to interpret uh, a project schedule along with material orders and personnel and equipment movement to define um, where congestion may occur at what stages of the project. To me, beyond cost, beyond uh, user uh, ease of use and the ability for personnel to learn the software systems. The most important component for a four-dimensional program is to be able to forecast four-dimensionally. And then the fifth research question is how do these systems interact? If you have an Excel-based solution, uh, are you able to deploy that on some of the fancier gadgets nowadays, say an iPad or an iPhone? Um, on the flip side, at the technologically diverse and complex side of the software systems, say you have a full-blown um, 5 or 6 dimension BIM platform like Revit or Navisworks. Um, Despite its robustness, are you going to be able to have that program interact with a simple Excel spreadsheet? Are you going to be able to incorporate that into your model? Are you going to be able to disseminate the results from that in a meaningful fashion to your project management personnel? So these are all questions that I had to face throughout this research project, and I believe I successfully answered or eliminated the need to answer all of them. So returning to the original, the genesis of this project, uh, the objective is to assess the current techniques, systems, platforms, software solutions that provide construction management with the ability to take a construction schedule and, sequential takeoffs or counts of the materials needed and possibly also constraints for the project or even as developed as a 3D model of the project and look into the future and identify at what point during work may spatial conflicts, time conflicts, congestion, any of the different forms of conflicts, when will they occur throughout this project? And beyond that, do the software offer tangible solutions that can be implemented by the personnel themselves? Um, the tasks that fell to me to complete this research project are identify the project risks posed by material congestion, both internal and external to the construction area. Um, Identifying risks is, a huge component of construction management, and that was my first task as a prelude to the discussion of the systems themselves. The second task is to identify the management systems, both paper-driven and software, that are available for use by construction management personnel to solve the problem of material management and congestion analysis. The third task is assessing these available solutions using the analytic hierarchy process for a given set of criteria. The criteria was established by myself, as were the solutions. Yeah, I would have been well served to submit uh, questionnaires to the student body in this course, um, research groups, even a survey through email. Unfortunately, I was unable to complete that component of the research. So having 15 years of experience in the trades, I felt that I was able to devise an analytic and appropriate enough set of criteria to begin the process of identifying which of these systems house four-dimension capability within them. And then the fourth task is obviously the execution of the analytic hierarchy process, which is a series of mathematical computations that rank the software systems against the criteria that they are presented against. So what you see here is simply a brief rundown of site material management definitions and the purpose of it. I'll leave this to you to better explore on your own, and we'll dive straight into the research that I conducted. So the initial steps to my systems research to identify the management solutions that are available for congestion analysis and material management provided a number of different options that I had to whittle down using step 2 to ensure that we're speaking only about solutions that are operable and functional in a digital environment. Um, as I spoke to earlier, I then determined the best comparative measure of systems capabilities relative to one another using the criteria I spoke to and the analytic hierarchy process to compare them all against one another. The 5 systems that resulted from my research are the Dynamic Site Layout Planning Program, the Pradhananga Simulation Model, the Congested Construction Logistics Planning System, the Nth Dimension Planning System, and the Building Information Modeling 4-Dimension Extension. As a brief introduction into the AHP, or the Analytic Hierarchy Process, it's a technique that was derived in the 70s, but was published here by Mr. Sadi in 1990, and it's comprised of qualitative and quantitative criteria that are ranked based on whatever evaluative process you want to use to determine a relative importance of one versus the other. There are then mathematical formula that are applied to the options that you have at your disposal relative to these criteria. You run them through a series of iterations to ensure that your rankings don't deviate too strongly from one iteration to the next to ensure a process of best fit. And then once the option eigenvector is determined and you have the criteria eigenvector, you multiply them together and you get a percentage ranking. And those options with the largest percentages are the ones that are the most successful in meeting your comparative criteria analysis. So the criteria I used for this assessment, in no ranking order, we'll get to that in a second, are the user-friendly capabilities of a software system, the ability for the software system to integrate with others, be it through data importation or pre-existing functionality, whether or not the system itself is schedule-based, it uses scheduling to determine conflict identification and solution generation options available to you down the road, that the solution considers internal and external space on the project, that the solution is dynamic, that it updates itself once new data is fed, and that the solution is able to provide you with options for resolving the conflicts that it identifies. So what you see here is a resulting sample of the data. You've got a pairwise comparison matrix here for the user-friendly criteria, the integrated criteria, and the schedule-based criteria. Again, these relative values were determined by myself, but they can also be sampled through a number of different ideographic means. These are the resulting numerical values of these, and then one of 3 squared power matrices is shown here to the right. So with respect to the 6 criteria chosen, and with respect to the 5 software solutions that we were assessing through this process, the Nth Dimension planning system more than doubled its nearest competitor with regards to the comparative criteria. The functionality of the program, its BIM integration, the forecasting capabilities, the ability to discern different types of conflict amongst multiple types of elements, the ability to generate quantitative solutions and also propagate those solutions throughout schedules, throughout material orders, throughout cost analyses. It really did prove to be the best in terms of the criteria that I was able to devise. So we'll follow that up with just a list of the references here, but I wanted to thank you very much for your time, Professor, and I greatly enjoyed the opportunity to research the subject for this module.